Storage used to be simple. You had a disk drive, you attached it to your system, boom, you got some storage. Then we created network storage and shared storage, blocks, files, object storage, and things got a little more complicated. Well, it's gotten way more complicated since that. Nowadays, it's kind of hard to understand even what storage is anymore. So we're here at the Storage Developer Conference and Storage Field Day asking the question and considering the statement that nobody really understands storage anymore. I'm Stephen Foskett from Gestalt IT, and this is the On-Premise IT podcast. Each episode, we bring together a group of IT luminaries to discuss a single concept or premise. We love to do these episodes together or on premises, and that's where we are right now at Storage Developer Conference in Fremont. So I've brought together a group of folks to discuss this concept. Does anyone really understand storage? I'm not sure I do. Before I begin, let's meet who's on the panel today.
Hi, my name is Jay Metz. I'm a technical director for systems design engineering for AMD. I'm also the chair of SNIA, and I don't understand storage.
I'm Andrea Mauro. I'm an IT consultant and Tech Field Day delegate. And you can follow on the infrastructure or Andrea Mauro on Twitter. And storage has changed so much.
Hi there, Eric Abelson, independent IT consultant working in France. I've been working with storage as a focus on all of my consulting things, and like you said, it's getting out of hand and harder and harder to keep track of all the stuff going on.
And I'm Andy Banta. I'm the storage janitor, and even being the storage janitor, I don't understand storage anymore either.
Well, I guess we don't even need to record this episode then. None of us
Very
understand
short meeting,
storage,
yeah.
and we are the storage people. So, Jay, I'm going to start with you. Mm-hmm. You are probably, at least by title, the person who should understand storage best. So what even is storage in 2023 and beyond?
Well, one of the funny things is that the more I learn, the more I have left to learn. So one of the things that we've been talking about here this week and the conversations we've been having with the DNA storage group and the SDXI group, with data movers, when you really dig down into it, it's trying to count the grains of sand on the beach. As the closer and closer you get, the more and more difficult it is to figure out exactly how many there are. And as we start to look at the scope of storage, you have to figure out which layer you're going to be good at. You're either going to be, something of a generalist, or you're going to be really, really, really specialized. But there is a finite amount of area under that curve. And so I admit my limitations to the best of my ability and know that there's much more I can do.
It's good when a man can admit his limitations.
Mm-hmm.
I think one of the problems we've been seeing in this whole thing is storage has always been the black sheep of the IT systems. You go into, one of my things is that I teach in a number of universities, and one of the things I keep running across is you will never find storage on the curriculum. We've got whole programs to push out stacks and stacks of network engineers, but there's nobody in there that is even trying to get a handle on storage. So how do we expect the professional community to have the basics to know what this stuff is, when even us as professionals that have been doing this for so long have a hard time keeping up, and the schools have just totally dropped the ball on this one. So we're having to take these people that have been trained as network engineers, at best, they're some of the best ones we have on hand anyway, and then bring them into the fold, bring them all up to speed on something that is just moving so incredibly fast that it's really hard to keep a handle on.
I got a great story about that, actually.
Mm-hmm.
So not too long ago, maybe 2017, 2018, something like that, I went to the OSCON conference, the open source conference. And there was a presentation done by a couple of young software engineers who were trying to talk about the comparison of their database choice versus the old database choice. And so they were showing graphs of the performance differences and the deltas and how much they were getting better performance. I said, this is really interesting. So what kind of storage were you using? And he said, well, we changed storage midway too. So we went from hard drives to flash. And I said, wait, so how much of this is because of the change of database and how much of it is storage? And he said, I don't understand the question.
Oh no.
And it really dawned, again, this is about 5-6 years ago, and it really dawned on me that it's only going to get worse, because as you start to look at the open source group or any other software group for that matter, there are so many layers of abstraction that they put into it that they're further and further and further away from direct placement, from data locality, for the zone namespaces and the way that things are being written and read to from media. The brilliant presentation that Andy and Kinyip did regarding memory and the buffering and caching that has to go on, that's so far removed from where most of the people are learning about technology, it just right over their heads.
And the worst part is, that's the developers who are more technical than most. And then you throw in management trying to make storage decisions about this stuff, and they're even further removed from, well, what does this stuff mean? And as I recall, and we still write, we're not working with a number of disk axes the most of the time, but still the question is, they measure it in its capacity. That's the only metric that filters its way and bubbles its way up to the management layer.
Yes and no, because the storage is just an infrastructure part. It's not only this, but is an infrastructure part. The focus always is on data, how you can manage the data, how you can provide the good service, how can you provide value of this, and the example of the database was incredible. Yeah, you are just focused at that level of abstraction that you don't care what is there. And maybe you make some big errors on how you compare this with this, because if I take a utility car and I compare with the fast car, still for, but it's not the same.
Definitely make
or a car of 20 years ago and the car, make no sense. But this gap, this abstraction, of course, is a huge problem, and I think that a lot of people does not absolutely care what is the storage, what is the compute part, how they are built, and it's normal because they have to think how programming or how use the data. Then there are the people that are working on make this possible, make this faster, make this truly fast in the best way, reliable, and all this stuff. But there is a huge gap between those two people, and sometimes people take decision without talk with both parts.
Well, and Jay's point is interesting when you don't care about the underlying media, and it's like, how can that matter? But another piece that Eric kind of brought up that a lot of people ignore as well is the networking involved. The storage transport is a huge part of the equation as well, and that's where an awful lot of networking knowledge is needed. There are so many people who are in the storage industry right now who don't understand the networking aspects and the transport required to actually get things around. So it's more often than not, it's actually going to be the transport that is the bottleneck in your storage system rather than the media itself. The media certainly plays a large part, especially in Jay's database example, but the transport actually requires far more development and isn't something that people think about a whole lot. In yesterday's roundtable discussion that we had at the Storage Field Day, find that at techfieldday.com, there was a comment from one of the people who worked in large data centers who said that storage consumes about 25 to 30% of the power in the data center. And I asked the question privately and didn't get an answer at that point. And it's like, is that simply the storage media, or is that taking into account the storage transport as well, which again is going to consume a lot of energy? So these are two different concepts that have to fit together, and there are very few people who actually understand both parts of it. My counterpart at the other end of the table, I know, has worked on both sides of it quite a bit, and I've worked probably more on the transport side than I actually have on the media side, but they're two very important parts of the same thing.
Well, it's going to get worse.
Yes.
Right? And the reason is because I've often said that there's a collision course between storage and memory. And you see the same patterns of exploration happening in different technologies. So I'll have to give two particular examples from opposite sides of the spectrum. One is the trend towards fabrics and CXL, where they're now having to deal with a completely different metaphor of a many-to-many relationship between different hosts, and put that through a transport, CXL, which comes with it things like oversubscription, fan-in ratios, hierarchical methods and topologies. Those are some of the things that memory people typically haven't had to deal with at the same level that somebody in a storage data center or enterprise would have to do. The other side of it is something like I'm also working in Ultra Ethernet, a new consortium designed specifically to deal with transport, from the physical layer up to the software layer. And there are a few of us inside of the group that are very storage oriented. Most of them are HPC and AI, and their attitude towards storage is, well, we do the hard stuff, we just have to have storage keep our bits for us. And to your point, you really resonated with me, particularly about those conversations about how those people are really focused on the fact that storage means capacity.
Yep.
And I've said this repeatedly, and I hate to be banging that drum all the time, but storage does not mean capacity, and it never has meant capacity. But that's the physical thing you can touch. That's the thing that people can go out to the local store and buy. They can buy a piece of hardware that will plug into something, and they can say, that's my storage. How much storage do you have? Well, I've got 14 terabytes. I've got 30 terabytes, or whatever it is. That's storage. No. Getting that bit to used, that's storage. And if you're talking about these really big scales, like we're talking about for Ultra Ethernet or high performance computing and these AI clusters, really big scales, million node clusters, you better stop thinking of storage as capacity. You're going to get in a world of hurt.
Absolutely. And that's one of the things that I tried to point out in my session at SDC just a little bit earlier today, is the complexity that's going to come with this is overwhelming. It's not something that you can sit down with a scratch pad and a pencil and figure out. It's the complexity of both the memory hierarchy and the storage hierarchy on top of each other is going to be unmanageable. And then you throw in things like Ultra Ethernet and CXL and TCP/IP and whatever else is in the mix, and you end up with speeds that are 6-7 orders of magnitude apart, as well as capacities that are near that as well.
Mm-hmm.
Well,
and that's one of the things I think that shocks me the most about where we are today in storage. Again, it used to be pretty straightforward. Everybody used roughly the same technologies. We don't even have the same technologies now. Not the same as then, but we have a dozen different transports. We have a dozen different medias, different topologies, different approaches, different protocols, and it's all storage. And so, for example, if Jay, you said, people try to determine storage in terms of capacity. If you had asked me 10 years ago what was the defining characteristic of storage, I would have absolutely at that point as well said it's not
Timing.
capacity, it's persistence.
yeah.
Persistence is what makes storage. And yet, we're talking about memory as a new kind of primary storage, sort of, that's not persistent. And then on the extreme other side, we're also, we heard today a presentation about DNA storage. You want to talk about persistence. That has none of the characteristics that we would want from an active storage media, but it sure does have persistence. That's one thing it absolutely has. Persistence, capacity, density, but not any of the other, latency, performance kind of characteristics that we would look at. And so, what is storage? We used to, remember tape was the sort of the ugly stepchild of storage, and we would say, well, yeah, that's storage too, but we don't want to talk about that now, right? Now we've got 10 different kinds of media. It really is a challenge because the truth is I can't fault people, software developers, machine learning engineers, database people. Well, I can fault them all day long, but I can't fault them for having the wrong idea about storage because it is such a big topic. So how do we address this, and what does this mean?
Well, that's been the thing that's been worrying me because for 20 years, 30 years, storage admin had to basically understand the hierarchy of how many disks do I need to provide XIO, and given a certain budget, what can I do with that? I had a choice of transports, which was really not difficult. It was fiber channel or Ethernet. and I didn't have anything else to work. I just had to figure out those basic axes. That's all I needed to learn about. And even that, the school systems aren't even teaching those basics. Now we have to introduce complex topology systems. I need to be a networking engineer to understand the various flavors of Ethernet, and all the new ones coming out online. I need to understand the impact of using something like TCP/IP over these different stacks, because that brings its own overhead. And even in the smaller shops, the biggest problem we're seeing here is you have to basically give a university level course to the existing administrators so they can understand what they're buying. And that's become a huge bottleneck in getting these new products into the market, because I have to not only explain it to their storage engineers, who are just basically keeping their existing systems running and have no bandwidth to come to these kind of conferences and discover all the new things that are happening. And that's leaving aside the whole management layer, which you have to explain to them. And how do you explain all this to management in small words?
Well, and along these same lines, I want to point out that in the past 20 or 30 years, the resiliency equation has changed dramatically as well. 20, 30 years ago, it would be, if you wanted to have resilient storage, you mirrored it. You had two copies of the same data that sat side by side. And along the way, the idea of RAID came along, ways of being more efficient and faster in terms of doing your resiliency. And Flash changed this equation even more so, where you end up needing to use something like erasure coding, where you don't end up hitting the wear limit of your flash by simply writing the same thing on multiple different caches. You need an algorithm that's efficient in the way that it actually wears the device, unlike previous ones. So even this part of the equation has gotten more complex, and nobody's teaching it. And I remember when I was in school, there were classes on algorithms that were necessary for doing resilience and that type of thing. Apparently not anymore.
Nope.
So where the things that I've been working on are even beyond that. I mean, they're not even teaching cursive in schools anymore, so forget about storage. But the thing is that one of the things that's been happening over the last couple of years that's kind of been under the radar for a lot of people is the placement of compute in different locations where they normally weren't there before. Compute inside the network, compute inside memory, compute inside the storage devices. So most of the storage people, not all, but most of the storage people are really focusing on the bits, moving the bits, getting the bits, protecting the bits, keeping the bits, sharing the bits, using the bits. But they're not quite so familiar with what happens inside of the processors, or the relationship between the processors and what's going on inside of storage. And quite frankly, the compute people are coming in with the attitude and the impressions that that storage is nothing but capacity. So the bias against storage goes both ways. And so one of the things that I've been trying to figure out how to reconceptualize the concept of computational storage, for instance. I really don't like the word computational storage, because to the uninitiated, to those who don't know the basics, it's slapping a processor on a flash drive.
Yeah.
Right? And nothing could be further from the truth. While those components exist, the whole promise of the premise of computational storage is that what we are doing is we are avoiding work. We are avoiding the movement of data that should not be moved. Now, that kind of absence, that negative space that just simply doesn't exist in a storage world. We're focusing on what is there and how we have to move things, not how do we stop ourselves from moving it. And last year at the Storage Developer Conference, Gary Greider from Lanol came and did a beautiful keynote about the work that he's doing on keeping the data in situ on the drives and doing processing and getting 9-fold orders of magnitude better performance. 9. Not times, 9 orders of magnitude better performance by processing that data there and not having to move 150 petabytes across the network. That's staggering amounts of savings. That's storage. That's what computational storage, and again, I hate the word, but if somebody can come up with a better word, let me know, because I'll put that in there real quick.
Intelligent storage comes to mind,
Yeah.
but the problem is the intelligence needs to be trained. It needs to be, we need to bring up a whole generation of storage developers that can bring that computing intelligence down to or closer to where the actual bits are living.
Yep.
Yeah, and there's going to be some fun stuff happening as well on the transport side that we're not seeing the same problem. If we can get it off the network, it's not just the IOs, it's the whole stack that comes into play when you start dealing with that stuff of being able to pull it away from the CPU and not, well, use another CPU where they're proliferating all over the place.
Yeah, but also this can change if we consider how the transport can increase in speed and in function, because we can make memory to memory from two different systems. That maybe can change also the idea that I have to make something close if I can do in the same way if I have a good transport behind. And I think that classification is becoming so difficult now, because also saying memory and the storage are a different type of level of one single pyramid where you have primary memory, secondary memory, and the persistent also, you have persistent memory that is a different type of RAM that we can have at first level. So probably storage can be classified is difficult, but maybe can be defined how store or contain data in an efficient way that can be from the space, from the performance, from the function point of view, because actually it is no more capacity, persistent performance, but is also a set of functions that you can have resiliency or durability or what else, local, remote, replication, snapshot, all this kind of thing.
So I'm going to say something kind of radical here. I think in 2023, the difference between storage and memory is no longer persistence.
Yeah.
I think it's political. I think that the difference between that memory is memory because memory is the domain of application developers, and storage is storage because it's not. And that points to a problem architecturally, technically, structurally, and I think it gets to the core of what we're having, the problems we're having here. I mean, this follows on what you've all been saying. How do we address this political problem, this domain issue, in order to continue? Well, because storage is going to move forward, technology is going to move forward, because product companies are going to be continuing to develop it. Some developers are going to nerd out about it and come up with new ideas. Storage is going to proceed and continue to develop, but how do we have this happen in a way that's going to be useful, that's going to be practical, and that's going to be functional?
Well, I can tell you what I've been trying to do to do that. Right. So, as chair of SNIA, I have been focusing on, well, two things. Well, the first thing I was doing is making sure that SNIA is prepared to be able to handle new projects that we would not have been able to do 5 years ago. Right? Because we were just a series of projects that were kind of working relatively independently. But now we're weaving a thread between the different projects and trying to ensure that it's a 1 + 1 = 3. What I do plus what you do equals a third thing that comes out of it. Now, not just inside of SNIA, but we're working with NVM Express, we're working with JEDEC, we're working with DMTF, we're working with these other groups, and we're exploring additional possibilities to create a Rosetta Stone, a lingua franca of vocabulary. Because quite frankly, when it comes to memory and processing and network, we're all using different terms, but they all sort of mean the same thing.
Or worse, we're using the same term
And different
way.
namespace is a really good example. Namespace and processing is not the same thing. Subnet and InfiniBand is not the same thing as subnet and Ethernet. Yep. That's even in networking, right?
Exactly.
So we're trying to come up with this kind of a mutually beneficial vocabulary, or at least a translation that is repeatable and across multiple organizations, even if we're not doing all the work in one group or another. So that's what we're trying to do over in SNIA is to effectively, create our own network of people and work and developers to be able to get to that endpoint.
And I mean, sort of addressing the political side of this, going back to a point you made a couple minutes ago, there's the specialization is actually something that's kind of hurting the entire industry simply because nobody else knows what anybody else is doing. Mm-hmm. And I mean, one of the things that I've noticed, especially in the storage industry, is the abstraction of newer software languages often mean that the people who are working on storage products don't understand how a processor works. And I mean, that's always been fundamental in terms of being able to get the most out of what you do. Is you actually need to understand how a processor works to be able to make the best use of it. And the people who understand how to make the processor work are the ones who consider storage just capacity. And the people who work on storage products and even storage protocol products, to some of my experience, really don't have a freaking clue how a CPU works. And that disconnect is part of what makes these groups of people not understand each other. And I think if you actually want to build really good storage systems, you need computer scientists who understand what a processor does.
Well, I think that's really important because the silo is not only political, it's also cultural. And the training side of it is one gap. We know that you can become a computer scientist and you won't learn anything about storage. You can become a network engineer and you won't learn anything about storage. And somehow we have storage engineers. Where do they come from? That's always been something that baffled me, is somebody had to wake up one day and go, this is cool stuff, this is interesting stuff, I'm going to have to learn it, and I have to learn it all on my own, which is one of the things I really like about the SNIA's initiatives about doing things like, let's develop a common language, because that's one of the advantages these other cultural groups have, is that when they use those words, they all know what they're talking about. And it's not just a political IT silo thing that just happened because that's the way the work was chopped up. It really is a cultural thing about what languages did you learn, how do you communicate with your peers, and if we don't come up with that lingua franca that we can use to communicate with the other IT silos so that we can contribute to that DevOps concept and things like that, we're in for a world of hurt.
Well, the good news about that is that, about 7-8 years ago, I started working with a library, or I started creating a library of back to basics, right?
Yes.
So I created, with some other people inside of the networking storage forum inside of SNIA, the Everything You Wanted to Know About Storage But Were Too Proud to Ask series.
Nice.
And I think we probably came up with about 20 different webinars going back to saying, what is RAID? What is block, file, and object? We went right back to the beginning. And I have to say, I got the best possible compliment I could. It was about 2018 or so. It was right before lockdowns and everything. And we had a summit with the NVM Express. And a guy comes up to me, I'd never met him before, and he said, I want to thank you. I said, okay. He said, I binge watched every single one of those back to basics, and it got me a job. And I was like, oh, that's cool. I mean, what I wanted to do is I wanted to create a series that I wanted to watch. I'd love to have somebody do that for compute. I would love to have somebody do that for memory. Right? Everything you wanted to know about memory but were too proud to ask. I would watch the hell out of that. Right? Everything you wanted to know about AI generative software. As long as you weren't trying to say, well, it's intuitively obvious to the casual observer that if you take slow down, Mr. Matrix Head, all right? I just need to know, define your terms for me, because a lot of them don't.
Yeah.
Define your terms for me, help me understand what you're doing, and I will help you understand what I'm doing, and that's how we can make it better.
Yeah, going back to the cultural level is very important, otherwise you don't have the base to construct something is the first step. Then can be interesting think what are we doing, because the entire way that programs are done are because CPU was only possible, was talking only with the primary memory and no other way to talk with the other pieces. And maybe now with all the opportunity, this model can be rethinked, because if you can move some data from a memory to a memory and transform this data during the movement, also the way that you think a normal program should be redesigned probably. We have a new opportunity that can probably change totally how we are working, not only from the technology like DNA storage, but how also we are we are building application because still are microservices, but still all the way to programming.
It really is an interesting conversation, and this discussion has turned in an interesting direction to me, and I'm sure to those of you who've been in academia as well. Doesn't this remind you of physicists and chemists and biologists talking to each other? Doesn't this remind you of social scientists talking to, I don't know, philosophers and psychologists? I mean, it's so funny because all endeavors, as you get deeper and deeper, you start developing your own culture, your own politics, your own phrases, and then you eventually realize, oh no, we're just not talking to each other at all. We're not learning from each other. We're duplicating efforts. We need to work together, and you need to break down those barriers. So I'm not surprised coming from you, Jay, that your attempt is a very academic attempt, which is let's define terms, let's figure out how we can work together, because that's what I would expect, and I think that is what the industry needs. So thank you very much for listening to this episode of the On-Premise IT podcast. Before we go, I'm just going to quickly go through where can we connect with you and continue this conversation.
You can find me on LinkedIn, obviously, or on Twitter /X at Dr. Jmetz, DRJMETZ, or jmetz.com is my blog.
Yeah, or LinkedIn or Twitter or my blog, infrastructure.it, and from there you can all have all the link.
So blog is at infrageeks.com. I'm now on Mastodon, so that's Eric at infrageeks.social, and the places to find me. And of course, everybody's on LinkedIn.
And I'm Andy Banta. I'm on LinkedIn and at Andy Banta on Twitter, not X, Twitter. And my blog is andybanta.substack.com.
Speaking of politics there, Andy. And I'm at Foskett on most of the socials, including X, Twitter, and Mastodon. And of course, you'll find me here on the On-Premise IT podcast, the Gestalt IT Rundown, and Utilizing Tech at gestaltit.com. Thanks for listening. This podcast is brought to you by gestaltit.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to gestaltit.com/podcast, and please do leave us a rating or review in your favorite podcast application. We're also found on YouTube at YouTube/GestaltIT video. Thanks so much for listening. I hope you enjoyed this, and we will catch you next week.